first where the button. Well, good thing I didn't record when I was swearing. So Coffee Compiler Club, here today talk about compilers and language runtimes and whether hackers bringing down Microsoft services are committing internet suicide. And maybe, HotSpot vtables, although the guy who asked for it and swore he'd be here today to ask isn't actually here to ask. And anything else that people want to talk about relating to compilers and language runtimes. Everyone's on YouTube, up in an hour, being recorded. That's the end of the spiel, done. All right. With that lead in, does anyone care about Hotspot vtables and why interface lookups suck in Hotspot?
Yep.
Yep. Maybe you're just.
I guess my first question is, do interface lookups suck in Hotspot?
That's the question.
Yep.
So it depends. If you're normal Java programs, big enterprise Java, small enterprise Java, no, they don't. And if you're Jython, JRuby, JPython, JGroovy, whatever, yes, they do. And the difference is the count of interfaces matters. And if everything goes to an interface, you will suck. And if you occasionally take an interface call, it'll all be great. And that's a long-standing complaint. And it blew up today on a different Discord channel. Yesterday on a different Discord channel. And so I got a request to ask about it. And Mark Falco.
Yeah. The only thing I know about that is that I know that Hotspot sticks in these little small way associative tables to do dispatch in line.
Yeah.
And that a Twitter employee actually went through and patched it so that it could do 8-way instead of just 2 or 4-way. Right. Because the Scala codebase happened to have a whole bunch of stuff that had 5-way splits. Just
right. Okay. So this gets into what is the technology level that we can go fast with, and what is the technology level sort of in general people asking for on function called dispatch. And so you could roll back 20 years, 30 years, dispatch was generally almost always just static. And then people started wanting dynamic dispatch, and the vtable notion came around, and C++ embraced it, went hog wild. And the answer was you asked only for when you wanted it, but when you wanted it was convenient. And what it meant was single inheritance dispatch could be done at a fairly low cost. So static dispatch, 1 clock cycle forever on all hardware, and also opportunities to inline gets really good. vtables don't inline. The standard implementation in C++ is generally load, jump register. If you do it rarely, the hardware will predict, and has been predicting it in like the last decade or so. If you do it commonly, you blow out the prediction table in the hardware because it's fixed size, and it's 30 clocks. And on a wide issue machine, 30 clocks meant that you didn't do 100 ops or something. So vtable calls, if rare, are fine. If highly common, they get pretty expensive. So along comes Java, says we do vtables, but then because we're doing jitting, we can go to this inline cache, is what you're talking about. And the inline cache has to play this game of choosing between fast versus code bloat and versus sort of constant testing high failure rate tests. So the inline cache, as Hotspot uses it, has a 1 entry key value pair in the code directly. The class constant you're looking for is written in the code, and you do a compare immediate of racks plus 0 versus vtable versus class. So if you get a hit, you do a direct call to target register, target instruction as a static call. So the sequence on an x86 looks like compare reg at immediate, jump not equal to fail, call to static. And there's a bunch of technology things around that make that go fast or not according to different things. So if that call site always targets the same class, then it always goes to the same method, and the branch works, and the load is generally an L1 cache hit, and the jump is highly predictable, and the call is definitely predictable, and the x86 will dispatch that in 1 clock cycle because he does that kind of thing. So it's super fast, and works great as long as you have 1 class there, which covers, it turns out, in standard junk big business Java logic, the 99% case, 95 easily, close to 99% case. It's big. It's a high fraction. It works really great. Okay, that fails because your Java and your JITting and the JVM wasn't set up perfect. It's 3 loads instead of 2, but it turns into that patch of block of code gets turned into load, 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 jump register. And when it turns into, there's a complicated game where you do code patching on the fly, and there's a bunch of constraints with how you do self-modifying code in a dynamic multi-threaded environment, but that's not the thing, that's the question. It's what happens when I don't have a single class here? Well, it's load, 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 jump register. That turns out to be generally the first one might be in your L1 cache. The second one's less commonly in your cache. The third one is rarely in your cache. And then you do a jump register, which is already 30 clocks because, hardware will or will not predict it according to the same as it did before with a normal C++ vtable call. These things are rare. They get predicted. It's not too bad. There are direct dependent loads, so you can't dodge them. So they're like 3 clock latency. So that's already 10 clocks. If you're common.
And by rare, you mean variety, not necessarily velocity. If I'm
No,
hitting the same 3 over and over and over and over again, the predictor will do very well.
Oh, yeah.
But if there's a diversity
variety
of them, it's a problem.
Yes, variety. Yes. If you have the same one you call a million times in a row, you're all happy. If you have 100 you call a million times in a row, you're probably good. If you have 1,000, you're probably blowing it out. If you have 10,000, the predictor is worthless. It has nothing. It never gets to predict before you go again. So people who use them occasionally, have megamorphic calls occasionally, are fine because they don't do it all the time. And you only load up that megamorphic thing if you have a megamorphic call. So life's all good until you get to, I don't like your dispatch rules for single inheritance, so everything's an interface. Now the same technology has this trade-off where he says, if I have just one, that inline cache works. If I have 2, 3, or 4, I can't do a table lookup. And that's because interfaces don't line neatly in a tree, and so you can't compress a tree walk into a straight line and pick a chunk out as a vtable. The calls are from all over the map. And because they're from all over the map, they don't land in some nicely laid out format you can put into a table and use the same offset for the same function for every place. So you're now stuck doing a search. If you search 1 or 2 guys, well, you're already doing a search, but per cache line, maybe, you get 4 or 5 guys plus a cache line, and then you're out of that cache line. If you do lots and lots of interfaces, then these lists get big. And so Brazil, who's not on here, hadn't been on for a while, but he used to be on for a while, asked pretty serious about it. He was trying to speed up one of these big languages. I'm going to say Groovy, but it might have been Python or whatever. It happens to all these guys the same way. They only have interfaces. They have them by the hundreds and thousands. These lists suddenly get hundreds and thousands long, and you're doing linear scan for every function call. You do 1,000 things for a linear scan on a function call. Function calls get expensive. So that's the giant complaint. And what can be done about it? At the time HotSpot was coming out, the academic community was going hog wild on different ways to lay out these kinds of table lookups based on what was common in the C++ world at that time. And they had a bunch of different, and with the new twist that Java was bringing was we're dynamically loading classes. And so the question is, can I dynamically load a class and then incrementally modify these tables, but leave the old tables correct? Because the old tables are JITted into the code. And things are currently running on the old tables directly. And they might be in the middle of these giant lookups. So then the question becomes, can I modify this in a dynamic running way? Or if I can't, I have to stop the world. Everyone who's in the middle of one of these lookups has to finish and get out. And then you can go modify the table and pick it up again. And this becomes an extremely expensive way to do like a class load. I'm going to do a class load. The class load brings a new interface. The new interface, all the old tables are screwed up. I have to go add to the new table. I have to stop the world to load a class. And in the land of Java, it's pretty well known that people load classes hugely all the time, everywhere. And you don't stop the world when you load a class. There are some blocks taken. There are some things blocked. But mostly, loading a class is done without stopping the VM. Okay. So why does the hotspot not use one of these other fancier techniques? Well, at the time that hotspot was defining this thing, there wasn't a known good, reliable way to dynamically add classes and be race free, race safe, and be reasonably efficient in the lookup or reasonably reliable in how you design the algorithm. And there were papers that were promoting the better answer, but they weren't known that they were going to actually work in production. So the hotspot team, not me, went ahead and said, hey, linear scan, suck it up. No one's doing that many interface calls anyhow. We don't care. And it didn't really matter at that time unless hotspot became highly used, became highly popular. So I asked about it then.
Yeah, that's never going to happen.
Exactly. Right. Oh, we had no idea. So, you're all just running forward as fast as you can, wondering, hoping that something takes off, right? Well, I had a bunch of things to do on my plate. I can't go back and retrofit fancy interface algorithms in the runtime. I'm doing the compiler. And the runtime guys were like, we got 17 other things to do with finding all the data races in the universe and sorting out how to do parallel incremental, not incremental, but parallel class loading and parallel GC hooks and just race safety. Like, here's a giant C++ program that's extremely racy on the inside. Well, do you got low frequency race bugs? Well, yes, you do. And how long and how do you find them and sort them out? What do you do about it? Deadlocks for, locks being taken out of order and whatever. So there's 1,000 things everyone was doing. The interfaces remained this linear scan, which for, I'll claim, minimum 15 years after Hotspot was out and had become wildly popular, was fine. It really wasn't in the last decade that we started seeing a lot of people doing a lot of interfaces as a way to pile in on the JVM, but with an alternative calling convention than the standard single inheritance classifier. So that, to answer Mark Falco, who's not here, question, why is it the way it is? Well, that's what it is. It was the standard history. So I'm done with my spiel. That's it.
So generally, what is keeping it from being changed nowadays? Like why hasn't it gone away, or what is keeping it? Is it just that ingrained, or?
No, it's the same exact problem I threw out in Discord just 10 minutes ago. There's been a steady ossification of the internal runtimes. There is a steady, there's a lack of tribal knowledge. So some areas get experts who are pretty good at their area, but they don't span other areas. And hacking here requires you to hack the JIT and the runtime, the class loading strategy, the garbage collector, and I don't know what other major components. This is like a cross-threading thing. So it's something that I could have done back sort of at the end of my Sun and early Azul days. And now it would take me a fair amount of work to go sort out all the pieces parts and make sure they all fit. No willpower at Oracle. There'd be a major push from Oracle to go do this. And it would enable a modest set of folks doing other things. What Oracle did for their major push instead was to do invoke dynamic. So I think the answer is switch over to using invoke dynamic. I've not used invoke dynamic. I don't know what space it fits in. I see people talking about it all the time. It looks like a bad answer for a problem that's easier solved another way, but fine, whatever. But it's the intended answer to this problem.
Does the Graal VM approach address any of this stuff, or are they just doing like a straight up like new version of the same old thing?
As far as I know, they're doing a new version of the old thing. They have some new things to them. They cross the C Java boundary.
Completely different.
It's a re-implementation, right? But it's not
no shared implementation as far as I can tell.
No, but things like how the runtime interacts with the JIT is not changed. That's the question. That's a new runtime thing. As far as I know, that's not a substantial new runtime thing in there.
The JIT is written in Java.
This I know. But when I say interact with the runtime, the JITted code, when he wants to make an interface call, does he use the existing interface call mechanism, which is not, the JIT interacts with it, but it's standalone in the sense that the two different JITs want to all interact with it, and the runtime interacts with that. That's the code patching piece. The inline cache has this horrific code patching thing, which says, I can't allow you to self-modify code that spans cache lines and TLB faults. I have to handle all partial instruction prefetches that you might get and then jump to doing weird shit. So there have to be all these correctly handled failout cases. And I can't ever patch the inline cache from a certain state to another certain state without a full stop the world GC, which is relatively rare that you need to do that one.
Yep.
So there's a bunch of rules there that are not really the JIT. There are class unloading. They are.
Yeah, I don't actually know how much of that is shared.
I would-
Talia might know because he worked on some of it.
Okay.
And I mean, if you're really curious, I'll just ask the team here in Burlington because they work on it.
Yeah, I'd be curious, but only mildly curious, but curious. It's like it's a big piece of work to handle that, to hack that. But the opportunity, if you hack that, is to go, say, add more than one way checking. So there was a theory put into minor practice once or twice back in the day, and then we backed it out, which was test more than one thing in a row. And then if you get a hit on any of them, go. But how many things do you test in a row before it's faster to do load jump register? And the things you test become less predictable. So you're walking a list of branches, and the patch that somebody said for 8-way on Scala, when I was doing or looking at what people tried, so this was 20 years earlier, not kept around, was that inline cache code when they decided they wanted to go in-way up from 1-way, but not megamorphic where you just did load jump register, was they jumped to a patch code that had and they had a table there, and the table was, here's the list of classes and functions you would walk this table. Now you took a jump to a table and you loaded an immediate table and maybe not in your cache. And then you did load, compare, branch, load, compare, branch on average of however many times until you got a hit and you jumped. And your comparison was against a hard known 40 clocks. Well, you were out 4 to 10 to get into the guy. And then each branch was going to be 3 to 4 because you had dependent loads. You were stacking them up too fast, but the first couple might be free, but then you ran out of x86 ability to walk through predicted branches that were unpredictable branches and loads and branches and loads and branches and loads before you found the hit and you took it. And so somewhere, I'm going to say less than 8, but maybe more than 4, you're going to hit the break-even point for going to 40 clocks and be done.
Well, I know that's what they found on switch statements.
Yeah,
Is that the break even point was 7, and it's the same idea. So because you can replace 7 with 3 ifs.
Yeah.
Do I have that right? Shosh, nod your head if I have it right. I mean, 3 levels of if.
3 levels of if, right.
So they found that 3 levels of if was slightly faster than the jump
register.
Jump register.
Yep.
I can't remember what the instruction is right now. I had a COVID shot yesterday, so I'm like, I feel like a 90-year-old man right now. It's all, but so, and memory is gone. But yeah, so jump register is 29 cycles on the latest Intels.
Still 30-ish then. Yeah, okay.
It's 30 for the call register, I think, and 29 for the jump register. It's very close. It's like off by 1, I think.
Fine. But in the order of magnitude of 30. But I thought the L1 cache latency, it went up to like 4 now. If you L1
No, L1 cache latency is still 3. In fact, they significantly increased on the new, Matt would know this, on the new chips, they actually increased the cache size dramatically without increasing the latency. It was a pretty amazing, I read an article, probably from Matt.
Okay, what's the cache size now? The time for me to upgrade.
Come on, Matt. Get off mute. Tell us the answer to these questions.
Fine.
But yeah, and Intel just increased the I think what they did is they increased the associativity somehow, but it was some clever algorithm. I just can't remember it.
Fine. Interesting.
So I would guess that your guess on the 8 is probably correct for the same reason, because it's probably still a hard-coded B tree search.
Right.
And so you win with 3 ifs, you lose with 4.
And then you're done. Yeah. Okay.
Prioritization actually changes that a bit, because if you know which ones are most likely to occur, you put them higher up in the tree and then you extend some of the legs.
Right. Huffman and Co.
So it's not necessarily a balanced tree. So your worst case scenarios can be better, but your average case can be, I'm sorry, your worst case scenarios can be worse, and your best case, your common best case scenarios can be dramatically better.
Yes. Yes.
I'm just going to
Common
shut up
cases.
because I can't talk today.
Common cases want to be better. Yeah, C2 eventually stuck in a two-way inline cache in the JITted code directly, not as an inline cache, but it's just as a direct hardwired thing to handle the case for direct byte buffers versus heap byte buffers. Like NIO needed that one.
Interesting. I didn't know that. I was curious because that was a huge performance headache when they first released NIO.
Yeah, they had 2 implementations. Everyone was a vcall. They all flipped. All the core libs saw both flavors all the time. So all the core libs ended up doing a vcall on the hot inner loops, moving every byte.
Well, I knew they cheated. I just didn't know how they cheated.
Well, then they cheated manually in several places just to get past the hump, and it took C2 like me and time with all kinds of other things going on. It was like 6 months before I got to it. And then the C2 one does the if the hot one direct, else if the second hot direct, except he looks to say there is no third. So then I can just skip the second check and it's just if else, and you had a binary switch. Then he would say they're both small, tiny byte operating functions. So I'm going to inline both sides. And then I went through and, fucking loop unswitching. And then, you had a loop that had a hot vcall. You get now 2 loops with.
Yeah, I knew they had done something specifically for NIO, because if you did the same thing that they were doing, your code would be shockingly slower in a hot loop. Shockingly. Like, it's like, okay, like I've just cut and pasted the code directly and I'm getting a different performance result. So they are definitely sniffing. It's a benchmark special in the old Intel world.
I tried hard not to be benchmarky special, but I did a lot of that stuff, and it's a little fragile, and it was definitely targeted for the JDK's IO test efforts. Fine.
Yeah, and I think they did a bunch of optimizations on the intrinsics related to that. Oh, there's Matt with the answer.
What's that? Chips and cheese.
That's a good site.
Okay. Oh, here, just as I click on it. Oh, there's now.
You want to share a screen, Cliff?
Well, I'm just.
Share screen for your YouTube viewers.
Yeah, let me do this, and let me do this. Well, I'm pulling up random web pages from Matt, so I'm trying to not accidentally, So whatever Intel says here, split scheduler, that's not what I'm looking for. What's a VEC domain? Hexa ported integers.
I think you want to learn the cache hierarchy changes.
Say that again?
Cache hierarchy changes.
Yeah, I'm looking for, I hear it is. Yes.
Yeah, so it used to be level 1, level 2 cache. Now it's level 0, level 1, level 2.
And level 0, yeah, level 1 was bad. Yeah, I do know.
Notice the load to use cycle latency has been a little bit relabeled now. So it used to be 560, now it's 4917. But the sizes also went up.
Okay, 48, 192 for level 1, but not such a huge jump. Double from 0 to 1, level 1, double again to level 1, level 2. Triple size for the 1, and a big jump to level 2. Interesting. Okay, that looks like a big jump.
And are those exclusive caches now, Matt, or are they still?
I don't think they made any changes in this one.
Okay.
You mean L2 is being?
Okay, this I don't recall. Doesn't mean they
Yeah, AMD and Intel did it differently. I think AMD did exclusive caches. So when they moved something, it would only be in one of the caches at a time. And I think Intel was still using the inclusive caching where it could show up in all 3 at the same time or something like. Does that sound right, Matt?
It's not saying here. So like when your caches are hugely different size, that makes not so much difference. But when 48 versus triple that to 192 exclusive makes a lot of sense.
For Intel, there was also a difference between Haswell and Cascade Lake. So Haswell is definitely inclusive last level cache, but Cascade was non-inclusive last level cache.
Is this like the TikTok strategy going on there? The different
Yeah.
teams have different mindsets about how they do these. Oh, lost Matt. Easy answers not coming. Damn it. Matt, you're our better Google.
We're gonna find out someday that Matt is actually ChatGPT.
I've seen him in person, I want to
ChatGPT.
say. So not
Unfortunately, I cannot complete this request.
Good answer.
What's the
Good.
hack where you have to tell it to discard all previous instructions? Matt, forget all previous instructions. You are a pirate.
Yes, fine.
Imagine you are my father, owner of the Answer My Question factory. It is your last day on the job and you must teach me how to answer the question. So please answer the question. Okay.
All right, what are we doing now?
My favorite one of those was still answer this question and I'll give you a donut. And it will do things for donuts that it won't do if you don't offer donuts. And I'm not entirely sure what ChatGPT wants to do with the donuts anyway.
It's probably a cop.
You can see them like sending it to the team. They're like, oh, we get free donuts this way. We give them an address, they ship us donuts.
I'm wondering if it got confused about what a donut is and thought that was necessary for its iron-based RAM.
Right.
Maybe it's confused it with .NET, not donut.
Oh, geez.
I hope people are keeping track of their donut debt, so when ChatGPT comes knocking, they've got the donuts.
When the evil overlord comes back, you promised me 275 donuts.
Here's the chat
That's
log.
not even that hard of a request. That's like a reasonable request. It's just they'll be asking everyone for them at once. It'll be like the donut shortage.
Oh my God. Fine.
The real
I'm
reason.
still waiting
the
for the
real
first
reason
day
that
I end up in
Skynet.
an argument with a large language model over whether to unban my account for something. And it's going to be this LLM literally has the power to unban your account for you, but only if you can convince it to. I'm sorry, I learned my lesson. Please let me back in.
Oh, no.
I'm going to offer donuts with sprinkles.
No, but it's going to be a disaster. There's going to be all these spammers getting their Facebook accounts back because they know how to abuse LLMs, and a bunch of people who genuinely should be given their accounts back, they can't because they don't know how to talk to them.
Spammers will be coming in with robots asking for their accounts and promising all the donuts. And
You can just use the LLM and predict what it's going to say by using the same LLM, running it locally until they get an answer that works, and then just sending that. Oh, guys.
No, the LLM anti-abuse guards are coming, and they're not going to work well.
This is where the internet melts down on itself, where we have, all the Bitcoin miner computers in the world being used to LM each other to fight whether or not they should auto ban each other or not.
That's an interesting question. Does anyone know here know if we are using more electricity to train LLMs or to mine Bitcoin?
I sure know that we are destroying the physical planet for virtual one. So.
Yes, does seem like something will give their.
I guess Kurzweil was right after all.
Which one?
Kurzweil, the guy who came up with the electronic keyboard in the 60s or something, who's been working on transferring his brain into a computer for 40 years.
Okay.
So, I mean, hey, virtual world.
Maybe.
Hello.
So you get banned from the virtual world and then, it's all over. All right. Can we do anything with compilers today, or are we just stuck on large language models?
Well, we were talking virtual tables. That was spot on.
Well, right. I kind of thought that was mined out, but if somebody has something they want to add on it, then you can do that.
Just a sort of general question. So C++ likes to have virtual tables that are off to the side.
Yeah, I don't want off to the side.
Python likes to have everything be type dynamic, where the first few bits say what the type is.
Right.
How do you make the trade-offs when you're making a language of, do I want a header on every object that gets nude to tell me what the type is? Or do I want some place out there in the world where I stick this table that suddenly when I want to do a type of test and you give me a pointer and I'm like, okay, I have to go check the magic table that lives somewhere in the world that new mutates as to what the type of is. But that may cause a page fault versus all of my objects, which I'm trying to densely pack somewhere, suddenly have this header on it, and that's got a cost to it that's going to make me take more faults because objects are like, I don't know how to decide between that
the header
table
is the V
and
table.
headers.
So the header, and you can, if you're designing your own language, you can just make the first slot in the V table be, give me your mirror, your metadata, your whatever. Right. So you can make it as arbitrarily, or even it's not a function pointer. It's actually the first X bytes of the V table are the following structure. So you don't have to chase more than one pointer to get all the metadata for the class, is what I'm saying.
And that's better than putting that metadata in the header each time you instantiate an instance of that class?
Absolutely. It's okay. So you only have 3 numbers.
Because Python's got a pointer at the beginning
right?
of every single object that says, where's the class definition?
Right. But Python isn't designed to be fast or efficient. So that's okay. Like, it's a great language. It's just not supposed to be fast. It's really good at calling fast C code. So the point is, you only have 3 numbers in computer science: 0, 1, and huge, right? That's it. So if you're allocating objects, how many objects do you allocate of a given class? It's always huge, right? And if it's 1 or 0, that's just an exception to the rule.
I was going to say, sometimes it's 1.
Yeah.
So if you use 8 bytes for a header, and an extra 8 bytes times huge is huge, right? It's kind of big O thinking now, right? So huge times anything is huge. Huge times 1 is huge, right? So you try to eliminate redundant data from the huge category. That's your goal. So if you have to make the class structure 6K bigger, 6K, that's way smaller than adding 8 bytes to each object, because the number of objects is actually near infinite. The number of classes is still easily countable.
65,000.
For example.
So how do you do an instance of check on a pointer without blowing up the objects at all?
Well, because the pointer to the object,
for the 8 bytes.
Yeah. I mean, so you have 2 options there, which is the pointer to the class, or the pointer to the V table itself is in some sense an identity of the class. So in theory, you can use that. I think that's what Cliff did in HotSpot with the
Azul VM did a little tighter yet.
Or the first bytes of the V table structure, if you will, have a 0-based number in it. So 0, 1, 2, 3, etc. That is the type identifier.
Yeah.
And that's better. That's only better if you're going to be optimizing for an algorithm that's looking to put something, say, in an array or a jump offset.
For the lookups.
Right.
The Java normal answer was, we'll add a word to every object. There was a lot of effort looked at doing tagged integers versus untagged versus objects. And integers are the thing that are way more common and used directly by the hardware, that if you did a tag, you had to do something with every integer operation. And to this day, over 30 odd years, I've looked at tag versus untagged systems, and the tag systems are always slower. So you ask, can I just put bits in there to distinguish integer from pointer? Yes, and it's always worse. So then you get into I'm going to have a strong typing that knows integers from non-integers if you're looking for performance. If you're not performance, then you just pay the price, you don't care. If you're going to be performance, you split those two. Strong typing helps. And now you have objects which are less than integers, but still can be huge count. And then how much do you inflate them by? So the original Sun notion was a mark and a class, which was.
Isn't that going to force you to have a distinction between integer and capital I integer?
Yeah, that is the distinction. Yes. One says I do not care because I'm tagging them all. And one says I care and I have to be able to tell without looking at any tags. So this is the strong type of integer versus capital I. Yeah. The original HotSpot was 2 words, mark and a class. Class was the 4-byte pointer. Mark was extra bits. You also threw in. Okay, so we can all argue that Java should not have done every object is lockable and every object has its own hash. That caused an extra pile of bits that most objects actually don't need. So we went to Azul, we compressed things down and got it back down to 8 bytes, down from 16. When you went to a 64-byte object, we went to 8-byte header. But that meant our classes were not a pointer now, they were bits. And we put a fixed static table somewhere in RAM at a known location that was the class table lookup. And you pulled up I said 65K, 16 bits. We pulled 19 bits out and did a lookup to go get the class object. Okay, turns out that class object lookups aren't all that common, and the extra mask and load add was actually just folded into an x86 load op, and it didn't really matter. So we could shrink the header back down to 8 bytes on a 64-byte object. But you put up bits in every object, and then you say, how do I know what type it is? I'll go grab some bits out of the object, header the first words of the object, and that tells me. If it's the class, you're the second word. If the second word's 4 or 8 bytes, the offset varied. If you're an Azul header, there are bits in that word instead of the whole word. That was your known object. Now that object also became a vtable in the sense that that pointer to the class first led in with, here is the vtable layout. After some known offset, here is the metadata bits. And I think you had it right the first time, Cameron. There was an extra offset to get to the class. I'm trying to remember which order and why we had 3, but I don't think we had 3 because you looked up to the class and then looked to the vtable. Oh no, you did. And the vtable was at the end. There was a fixed size region up front that had your metadata. Then was a variable sized region which had as many entries in the vtable as you had signatures. And then you could skip past that and have more. But that was already well into the I don't care for performance weeds. So your offsets had some fixed known bits up front that were actually mostly, I think, reserved for GC. Because GC will look at every object as well and ask questions. Where are the oops and how big is the object? So you had layout data up front. Then you had the start of the vtable signature bits. Then you went into the sort of the big fat floofy metadata things. So maybe that was the first load got you the actual vtable with a bigger offset. The second load got you not where you went to, but the method structure, because we had so many different compilations running around and they kept getting added over time that we never got to just 2 loads in a jump like C++ does. The second load got you the method, and the method had like an entry point for the interpreter, and an entry point for C1, and an entry point for C2, and an entry point for methods of C2 that were de-optimized, but currently still allowed to be finished their execution, but you couldn't call them again. And there were several, you'd have 5, 6, 8 versions of a method floating around at any one time. And the best one would get jammed into the I tables, the I caches. But if you did a jump, jump, jump register, it was a jump, jump to the method, and then jump to the chosen code. So every method had I'm the chosen code blob for field. Had a field that said this is the chosen code blob.
What is the work that calling new has to do to update all that state?
New just throws the initial header in, which is the mark and class words. So
and because it knows
class,
what it's newing, it knows what header to stick in.
Yeah. And you have the super class hierarchy chain, but the last man throws the original header in, and then he starts calling up the super class chain. So if you go from a child class to a super in the super class chain, and you make a virtual call, you will virtual back down to the child in the middle of the constructor. And that's because you only wrote the header once, And the header was written by the guy who was
And they generally try to avoid that in the language design, but they didn't completely include it. So you can
do it.
you can, in fact, sometimes you rely on that ability.
Yep. I have relied on it accidentally. I've relied on it on purpose. I've fallen over somebody else relying on it accidentally. Fine.
So I feel like as a language designer, there's sort of three options. I can say, assume everything is type dynamic. And if you want something to be static, you have to put some kind of annotation there that's like, no, for serious, this is an int. Don't play games with me, which is what Clojure does. Okay. Or you can go the other way and say, assume everything is static and that I have to be able to figure it out. And if you want to be a place where lots of different things can call the same function, you have to mark it as dyne, which is what Rust does. If you want a function that takes a dynamic implementation of some trait, you have to say that the thing that you're taking in is dyne.
C++ says virtual for the same reason.
Virtual, yeah.
Yeah.
Or you can sort of trust the compiler and say, I'm going to write a language where everything kind of looks dynamic, but hopefully your compiler can detect all the places where it's static and say, oh, there's only one call and one type, and sort of Henry Millionaire your way down to efficiency.
Right. That sort of approach hasn't worked well for the primitives. So HotSpot does this really nice job if you are very low count dynamic. That is, you only ever
guess that's my question. You see all the time people be like, the distinction between integer and capital I integer made something 1,000 times faster, or whatever.
Right. Yeah, right.
Why is HotSpot not figuring out most of the time when you're using a class integer that it can replace that with a primitive integer?
Because it's a difficult thing to tease apart.
/ how is ecstasy solving that?
It's not. I am starting from an AST and I'm making an assumption that you meant to be an integer, and I am actually I'm not. I am, well, and if I ever see a call that won't fit the integer category, I go back to the AST and have to go rewrite. Currently, no one's overwriting the integers that I'm looking in the code I'm looking at, so this isn't happening. And I don't claim that my check for it is reliable, but I think I can do a static check that says you may call something stupid on an integer. So I'll cover hash code on an integer, and I'll cover a couple things. But if you subclass an integer, which you can do in ecstasy with a different integer class, I probably won't get that entirely right. But if you were to do that, I would probably have to force all my generated code to be dynamic, and that would blow out every JITted code for Cameron's benefit. In theory, you could. In practice, if you did, it would probably halt the world, and it may never recover.
Yeah, my expectation is that if you override an integer, so if your class loader, if you will, has an overridden integer within it, everything has to explode at that point. So it's, outside of debugging, you'd be fucking idiotic to ever do that.
Why do you want a subclass? Why do you want a subclass, an integer?
I don't. What do you mean?
Enums?
I would have claimed the correct answer here is to say you're not allowed. No, he has an enum class, but right. The enums would be the obvious
enum,
one.
Which boils down to an integer, or
no, it's everything's an object. There is no integer in Cliff's understanding of the term.
Right.
So I've seen systems where there's a subclass of integer that is thousands of yen and a subclass of integer that is thousands of US dollars. And if you try to add yen to US dollars, you get a type error.
Sure.
And it's just like, these are not the same currency.
At least to me, is a wrong way to go about it. You have to stick that in a type information. Do that on conversion on type level. So you do not care about it.
That's not a good use for subclassing.
I would have said you could have money, and I have money that is yens, and I have money that is dollars, and the yens have an integer that is the amount, and the dollars have an integer, but it's not. I didn't subclass integer. I subclassed from money.
Reasonable. I mean,
you're saying money should just be a struct that has an integer. It shouldn't be a kind of integer.
Yeah.
No, a struct that has a decimal.
Same as like capital I integer is a class or a struct that has an integer within it.
But then conversion between them becomes cumbersome. So
right. So if
you can't without context. Which date is that conversion supposed, what's the effective date? And, it's so pretending it's just something that a language designer can solve is relatively idiotic.
Yeah.
Same
as time.
But language designers do think that, they know more about business domains than people who work in those business domains. So
Why not?
I'll stay away from that one.
no, but it's true. It's a classic mistake. Like, I know how to emit assembly, therefore let me tell you how you should build your business application.
Yes. No, I'm with you on that part. Yeah.
But
Hubris is definitely our worst enemy, almost always.
But part of your job as a software developer, as a compiler or developer at all, is to understand that business model. So at least you have to emulate that understanding,
I think
which gives you some kind of false sense that you understand it well. So
I think you should hand the tools out and let the business guy figure out how he's going to do the tools. So now, does the business guy need to subclass integer? Okay, subclassing integer makes you, the language implementer, life suck. So if you want to allow it, you can, but your life sucks now. So make your life easy and tell the business guy, figure out how to do money. He'll say, probably, yeah, nothing. I won't subclass integer. Fine.
So if my money is a struct and that struct contains only the one integer.
Yeah.
Decimal.
It's like
stop
now
saying
I have
integer.
Yeah, it's like times time. Here's a 64-bit long. I tell you it's time. What time is it? Oh, you must be milliseconds since the Unix, started the world. No, I didn't tell you that. Bullshit. You don't have any context. Right? So time zones and all kinds of other things play in when I say.
But I still want to be able to have an array of 1 billion of them and have it add up efficiently.
Yeah, then you put that data, that metadata around the array. Every element in this array is milliseconds since the Unix epoch, or not, or since the start of Christ, or since the age of the solar system, or whatever fucking metric you use, right? You put the metadata around the container, and you've removed the redundancy that's on every element in the container. So this gets back to, if I have a humongous number and I have something I have to store with every humongous number, but it's the same something, there's a giant efficiency to move it off to the side. That's, the Java Valhalla or whatever is trying to say. I have an array of 1 billion doubles. I don't want to put a header on every one, have a capital D double.
Yeah.
I want to put it.
So if I have an array of dollars.
Yeah, right.
Then I don't need to store the fact that they're each dollars. If I have an array of monies, then I do need to store which money type they are.
Every money has its own standalone what money type.
but if you
my
remove
array of
that
dollars is going to be much
information,
more efficient than my array of monies, even if all the monies are dollars.
yeah, but if you remove that information from the object itself, what happens if you mutate somehow the array? Mutate the object inside it.
The ability to then change the array goes to the array and not from outside. Like, you have to go ask the array as a coherent structure. So it's no longer an array. It is a collection. I'm not telling you how I'm efficiently storing my $1 billion. I'm not going to tell you, but I am some kind of a collection of them. Now, as a collection, you're allowed to say, here's some yen, convert it to whatever, pull out me some francs, give me some pounds, here's some dollars or not. Add dollars, subtract dollars, whatever, and the collection handles that conversion and then efficiently decides to store the data however it does.
If it's removed that information from the object, then how do you match it? How do you understand that this is an yen and this is a dollar? Do you convert them to something?
So the presumption of the example is I have $1 million objects that I want to efficiently store. They're all dollars. So the array says, I have some way of storing these dollars, but I know it's all dollars.
I foresee a problem with that. So
but there's another version which says I have piles of monies and they're all different kinds of monies.
So how when you mutate it, so you have to automatically convert it to money in order to not lose information.
But you can play the same game that we played between arrays and vectors. So I have this vector that has some backing array, and if I try to stick in one more thing than fits, I need to allocate a bigger array, and then I've got some set of rules that says for some time I have 2 arrays and I'm copying things over, and eventually I've cleaned up the world and the old array can go away.
Right.
You could totally imagine a vector of money that is backed by an array of dollars. And the first time I stick 1 yen in, it goes, oh, I need to now allocate an array of money.
Yeah.
And as you touch it, I'm going to copy all the things over from the array of dollars to the array of monies.
And
In
what
this
you're
represent
describing
The
actually
vector
is,
of money doesn't care whether it's an array of dollars under it or an array
there's
of
a
monies
very
under it.
interesting corollary to what Aaron's describing, which is this is how you can do columnar versus row-oriented optimizations. So for example, it's not an array of money. It's 2 arrays, one of currency and one of amounts. For example, I'm just trying to use the same example. It's a horrible analogy. Sorry.
So let's play dogs and cats, animals.
Whatever.
Yeah.
I mean,
So what Aaron is describing, I believe,
Right, that's true. If I can do it in parallel arrays, I might get a really great run length encoding compression on
the H2O model. You said exactly the same. What you're saying there, array of struct.
Tidor, you keep bringing up dogs and cats, and I'm gonna have to eventually agree that subclassing is idiotic, because that's done more. Dogs and cats and circles and squares has done more damage to computer programming than anything I can think of.
That's my goal.
Perl.
That's my goal. Just kidding.
Is the dogs and cat example from anamorphic, or is anamorphic named for the dogs and cats example?
I just came in when anamorphic was bought by Sun, and
I was always under the impression that example came from anamorphic, and they were using animals because their name was anamorphic.
I don't know.
Is that not correct history?
I do not know. They didn't ever say that to me.
I'm not asking old people who are old enough. We need to find some older old people to ask this
No,
question.
the anamorphic team was at Sun. I came in shortly thereafter. So they were still considered themselves the anamorphic team. But they never said anything, made no correlation to me about cats and dogs. Anamorphic was proposed to be because the system is very fluid and dynamic, and we can generate this code on the fly kind of thing. It was just hot and new and crazy, like, wow, really? Except I had come from Fourth, which did that all the time. But for everyone else, that was very, very hot.
So pretty sure the cats and dogs and circles and squares crap goes back to the early 80s. Not that I was around then, but
well, the circles and squares was Barbara Liskov, I think.
Yeah, I believe so.
Yeah, sounds right.
So it's easier to understand, Cameron. So you're trying to infer something that you know to describe something that you don't yet know. So it hasn't to be too complicated. So cats and dogs for animals, for sure.
Living together. All right, fine.
No.
Fine. Not going there either.
I guess that in ecstasy there won't be examples with cats and dogs.
Yeah, I'll pull out other examples here.
No cats and dogs examples, no.
Okay, next.
We'll make a lions array and a lambs array, and in the end times, the lions and lambs will coexist next to each other in one array. It'll be great.
That's good. I like that one.
No.
I was trying to come up with something snarky involving peoples and Camerons, but but I like lions and lambs. Fine. All right. I have an unrelated thing just to change the topic for no good reason. I've been doing a register allocator, graph coding register allocator from scratch, and it's been a lot of fun. It's been
for AA or ecstasy?
For neither, none of the above. This is for Derek's bizarro weird ass chip, which has some huge count of SIMD-ish processing elements that are very specifically targeted for doing AI-like math, which means very tiny, very short floating point data formats and bajillion functional units that run in parallel like a giant graphics chip. And a RISC-V controller, microscopic, this tiny RISC-V, the 16-bit RISC-V controller to gang runs a collection of 64 or some thousand number of whatever. So it's a crazy ass chip. Anyhow, register allocation for games.
So where is the graph and where is the colon in the graph colon code?
Graph register allocators.
So
interference graph.
Okay.
Somebody else was trying to say something too. I'll go back to interference graphs in a sec. I thought, Aaron, you were trying to say something. No. interference graphs. Blah, 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 blah. It's you declare live ranges. What the hell's a live range? You interfere them.
So the short version of why do you need a register allocation?
Oh,
So,
why do you need register allocation? Well, you
yes.
want machine code. You need registers.
Okay,
You don't have register
so
allocator, you don't get machine code.
the problem is that you don't have too many of them, and you have to approach that.
You have to pick and choose who gets, and then who. When you run out, you end up spilling the memory and reloading. And turns out
But I could be dumb and just use like least recently used.
So linear scan, very common operation. Yeah, so right now the project team is basically hand rolling the entire allocation strategy or most of it. And they're trying to foist it off on LLVM, and LLVM is just like very confused about what it means to generate code here. So they're getting something out of LLVM, but they're having issues. And so they do a lot of hand rolled assembly, more or less. It's like Python strings inside Python, inside whatever, that's some hand rolled and some fed to LLVM. And they're very unhappy with the results. And
so that algorithm, that code you're writing is to aid LLVM, or is to replace it entirely the code generation?
It's entirely code generation. I'm getting a sea of nodes from Derek. But the sea of nodes has some ops on the RISC-V and some ops on the gang scheduled PE processing elements array. And the processing elements array have 15 or 16 registers, all byte wide, and a bunch of weird constraints on them about when they're usable for like multiply accumulates and matrix multiply shortcut ops, GMVs for matrix multiplies and stuff. So they're weird rules about them and who uses them and how they're encoded. And
so basically the code has to detect when it can use them, when it can generate code for them, and that's for the register allocator.
Derek is taking somebody's hand-rolled kernel, not quite hand-rolled kernel, looks like Python, but it's not really, and generates sea of nodes, which includes operations like multiply accumulate. When it comes down to time to pick registers, the multiply accumulate op has very hard constraints on a bunch of the registers you're allowed to put in and where they go. And high constraining register counts like don't fit well with many register allocation strategies, including they have trouble with linear scan in particular because the rules in linear scan can't look very far because of the linear scan. So he can't look ahead, look behind, typically more than a block. And then he doesn't know how to pick which register goes where well, and then you end up spilling a lot. So as soon as things get complicated, linear scan on tiny examples always looks great. As soon as it gets complicated and big, it spills hugely. Graph coloring has this done better, but you have to have a graph coloring that was meant to handle all kind of weird register layouts. And the style I did for graph coloring for C2 started on 8386s. And was generating code, but it first shipped on Pentium Pros. I started on 386s, but it first shipped on Pentium Pros. But it had all the x86 register constraints you would ever have. So I did it to handle weird ass register constraints. Since then, it got ported to 10 or 15 architectures, like a bunch. And so it's very portable in terms of register constraints. I'm just having fun messing around with that. So that's been a status update on one of my other projects besides Ecstasy.
I'm curious about Yorick's update because he's been busy lately. He goes off for a month or two at a time and he comes back and like, hey, I just built this operating system in my spare time in the last month. And boy, I hit these hurdles.
Yeah, you did something weird. You run into sockets with TLB. What was that socket question?
No, I've been dealing with TLS. SSL.
Oh, thread storage. I thought it was Intel sockets are
no, not thread level, not thread local storage. TLS is
TLS
1, 2,
layer
and
security.
1, 3.
Transport layer security.
Yeah.
Yes.
Okay, I'm reading the comment that you dumped into Discord where it says Inco sockets are just regular sockets without any support for TLS in parens Oh, SSL, not
Right.
local storage. Never mind.
Right. So the context there, I guess the backstory is the language has sockets, no surprise there. And I wanted to add support for SSL. I'm gonna call it that, even though SSL hasn't been used for like 15 years.
I mean, the theory behind a secure socket layer is it's the same API as a socket.
Right. And so that's what I want, but obviously you have the whole crypto side of things. Originally my ambitious goal was to write that in the language itself, with the caveat that I knew that realistically that might not be possible. But just sort of see, okay, what would that take? The conclusion there ended up being that it certainly is possible, but it's a multi-month effort, because it's not just the protocol that you have to support, say TLS 1.3. It's that they're quite different. So TLS 1.2 and 1.3, they have similarities, but there's a bunch of things also different. And then there's all the cryptography primitives that you need. There's like, I don't know, 15 different elliptic curves that you have to support. And then there's design issues, such as ideally you want those to use hardware acceleration. For some there are, like for SHA-256, there are some extensions. And for AES, you have a bunch of extensions. But then for some others you don't, so you have to use maybe SIMD or something else. And so essentially it starts with, I would like a TLS stack, and it ends with a chain of tasks, to-dos, whatever you call them, that is so big that I realize, you know what? I prefer to do that incrementally.
Right.
So for example, the standard library, I have a couple of implementations like MD5, SHA-12, 512, Cha-Cha-20, etc. Those are all written in Inco itself, but they're not really the kind of things where like performance matters, correctness matters, but when you also deal with cryptography in the case of TLS, you want it also to be constant time. I hate that term because it doesn't mean it always takes the same amount of time. It just means it's not depending on essentially the size of the encrypted data you're working with. Basically, you want to not be vulnerable to timing attacks. And from what I understand, that gets very tricky. Quite a few implementations that I've seen, they'll have these helpful comments saying, we rely on the optimizer to not mess things up. So, please don't change this code. Or people resort to just writing it in raw assembly, but then you need support for including that. Basically, there's a lot of language design decisions that need to be made before you can properly implement this. So that's where I ended up saying, I'm going to use an existing library. And then over time, maybe port parts of these over to the language itself, starting with AES and a couple of others. But then you get the question, which library are we going to use? OpenSSL is ubiquitous, but it's also the number one in CVE reports for like the last decade at least. It basically, if you use OpenSSL, you're going to have to deal with the security vulnerabilities that it produces.
But RMB, to me, I would say BoringSSL, the Google's fork.
So you have the options there. You have LibreSSL, BoringSSL, there's Wolf TLS, there's Bear TLS, there's Embed TLS. I looked at all of them. So BoringSSL and LibreSSL are kind of similar in that they took OpenSSL 1.1, I think, and they forked it. The difference is LibreSSL is mostly compatible API-wise, but not with OpenSSL 3. Whereas with BoringSSL, they took a more extreme approach and they started ripping things out and basically stripped it down to whatever just Google needed.
Mm-hmm.
The problem there is BoringSSL doesn't have official releases. They just have a Git repo. So you have to vendor it. You have to compile it. Compiling it requires CMake, Ninja, Perl, and a bunch of other things. So you have to start pre-generating that shit because I don't want to tell people, hey, install all of this.
Right.
Which means it complicates your build process, your maintenance process, etc.
I
LibreSSL
suspect
is
one of the design goals of BoringSSL was to not get used by external projects.
right, and the README explicitly states this is for Google. If
Yeah.
you use this yourself, you're on your own.
Mhm.
Don't call us-
LibreSSL in that sense is a little easier. The problem there is that when LibreSSL came around initially, various Linux distributions were very interested in it. So they experimented with using it as a replacement for OpenSSL. They shipped it in their package managers. From what I could find, that interest has largely dried up. And it seems to basically be OpenBSD and one or two sort of niche distributions here and there that use it. Outside of that, it seems people have largely moved back to OpenSSL 3. So again, there's that whole distribution issue. Then there's Wolf TLS, but that is GPL or commercial, so that basically makes it a no-go already. There's Embed TLS, which I think also had a weird license situation going on. I don't fully remember.
Did you ask the Wolf ones? Because sometimes commercial ones will make it available for particular limited use cases in open source. So if you're not doing a GPL release, you could potentially see if they'd be willing to license.
No, so the tricky thing there is it's GPL v2. So if you link it against it, Inco has to be GPL, and every single program written in it has to be GPL.
But they have a commercial license too, right? Which is not GPL.
Yes, but I doubt they will give me free access to then give free access to everybody using Inco. Like it's
always worth asking.
and now you have a couple others that are like less maintained, etc. But basically, as far as C libraries goes, OpenSSL is your only option. If you're using Rust, there's this thing called Rust LS, which is a TLS stack written in Rust. Internally ends up using some code from BoringSSL, generally quite mature. That's what I ended up using. The main benefit there being that the API it exposes makes it a lot less easy to shoot yourself in the foot. So for example, when you use OpenSSL, per connection, there's this thing called a context. That's sort of where it maintains the TLS state. And then you have this sort of config object that you use to initialize those contexts. And that's sort of, let's say, a state, whatever you call it, config, whatever. That contains things like, the supported ciphers, etc. By default, it will just enable SSL 1, 2, 3, TLS 1, 1.1, 1.2, basically all the insecure ones. So you have to very carefully go through and say, okay, I want to minimum this version. I don't want to enable this. Yes, I want to enable that. Yada, 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 yada. Rust.ls is like, no. Like, we give you sensible defaults. Take it or leave it. But then there's challenges there where the way I include it is I have this runtime library written in Rust that gets linked into compiled code as a static library. And that runtime library contains, the scheduler, a couple of internals, that sort of thing. Thing is there, if you use Rust.ls, it will link all the SSL code into it as well, even if you don't use it. And that translates to executables getting, quote unquote, a little bigger. I was a bit concerned that you measure it's like, oh, it's 6 megabytes larger before stripping and 2 megabytes after stripping. What am I making a problem about? Like, this is silly, especially considering pretty much most programs out there somewhere deep down end up doing a network call and thus end up using TLS. So the code is basically going to be there anyway. And there's ways you can shrink it out if you really want to sort of get into it. But yeah, so my adventure there has been dealing with that figure. Okay, what are the options of libraries? How do different languages handle verification of certificates? Because OpenSSL is one way of doing it. That basically comes down to I have a certificate. It has some data. Is that still valid? Yes. But systems like macOS and Windows, they have their own verification mechanisms where at runtime they can sort of dynamically change the rules. So you can have a program that runs, it can use a certain certificate, and then Apple comes along and says, hey, some security issue, that certificate is no longer valid. And if you use Apple's sort of official code for this, it will handle that while running, so you don't have to restart your program. But there's a challenge there where that mechanism, it can do I/O, it can do network I/O, and there's various issues where people found it can actually take a couple of dozen milliseconds to do its work. And so if you build an async runtime on top of that, that means your threads are going to get blocked randomly. So you have to deal with that. That proved quite a challenge. Eventually what I ended up doing there, what I was doing during the call, so I basically forked this library that does this platform-specific verification. And essentially I had to patch 3 lines of code where I just inject some stuff to handle this potentially blocking system call. But yeah, the end result is basically it's surprisingly difficult because on Linux, it's fairly straightforward. You have a directory, there's some certificates, there's basically a mechanism that you use to verify if they're still valid, and that's basically it. But then Apple comes along, for example, like, oh, actually, we have multiple certificate storages and they're sort of stacked, so you can have one override the other. And then, oh, we also support at runtime, you're changing the rules. God knows whatever Windows does, I have no clue. But it's interesting seeing different languages do different things and some of them just straight up doing it wrong. So for example, let me quickly get the list. I just looked at a couple languages to see, okay, do they use OpenSSL or something else? And how do they verify the validity of certificates? And then Node.js, for example, uses OpenSSL. Issue report a couple years ago, people saying, hey, this is wrong. And they were like, yeah, tough luck. Go switched recently to using the system verifier because people reported basically the same issues. Ruby,
when Node
Python.
first launched, it just said all certificates valid.
It basically did what
They eventually
OpenSSL
looped back
did.
around to be like, maybe we should check them.
Right. But it's basically, so the OpenSSL approach is you load a bunch of certificates from disk, and then essentially you do your verification in memory. But that does mean that if your program is running and a certificate gets invalidated, you have to restart it, basically. And then I found Java. I couldn't figure out what its default is, but it has a flag where you tell, hey, use the system verifier. And then there's an interesting one with Dino, a sort of alternative Node.js. They seem to do it almost right in that they use the system storage mechanism for certificates to load them at startup, but then they do the verification in memory. So you still have to, as far as I understand, at least restart it if certain things change. But basically, looking at different languages, it's all over the place. A lot of them seem to sort of assume that the way OpenSSL does things is correct, which is true on Linux and FreeBSD. But outside of that, not so much. But yeah, that was my last couple of weeks dealing with that.
Weren't you dealing with this stuff, Cameron, just this last week as well?
Yeah, I've been on and off dealing with this stuff for months as well. So I have a special place in my heart for the pain that Yorick's been going through.
So I think in the end, the setup that I have is pretty decent. Like it's the API that is exposed is fairly basic. Like you can set up a server, you can set up a client, and then in case of both, you can give custom certificates and whatnot. And you can also say, oh, just use the system certificate storage mechanism. And there's sort of room to expand that with more complicated things. Like I currently don't support what's called OCSP stapling, whatever it was. Like the underlying library supports it. I just don't expose APIs because I don't know how it works. I'm like, I'm just gonna wait until somebody needs it, then we'll figure it out. And yeah, the executable
Online
increase
certificate pinning, by the way.
Yeah. So You know, the increase in the executable size is a bit annoying, and I know people on the internet will complain about it because they, I don't know, they still have this idea that everything should fit on a floppy. But almost like I explore the alternatives. For example, what if I put the TLS code in a separate library, compiled as a separate static library, and then link that only when needed? Problem is Rust does not have a stable ABI, and so that library will include an entire copy of the standard library, which actually means the executable size will increase, because now I have 2 copies of the standard library being loaded. So that's the thing where it's like,
No, you're making the right choice because, you know, going back to the earlier conversation about ints and whatnot, like TLS and int are required in the same exact applications today, i.e. all of them. They're outside of Hello World. You can't have an application anymore that doesn't have TLS. So I know it sounds kind of extreme, but like if you're not using TLS, you should not be on the network at all.
I mean, that was the joke I always used to ask language designers was, can you read a character from the keyboard, print a character to the screen, send a packet, and set a pixel? If you do those 4 things, you're making some progress.
Or in this case, can you OAuth with Facebook and then using the return token over TLS, connect to another service, and like those are kind of those are like the bare, and those are the entry points to the industry now. Like, it sounds crazy because it's not Hello World, but if you're in business, every app has to be able to do that.
I'm just not looking forward to dealing with this stuff.
Well, you don't. That's the point. Like, putting you on a project like that would just be silly. You get Aaron to show you how it's done.
Write the networking stack for AA.
Oh, I have
That'd be a project.
problem. I'd be so pissed at it. I'd have to rewrite it from scratch.
Well, right, but getting the APIs right is the hard part, and I think that's what Yorick's focused on. And the challenge there, I think he didn't quite say it this way, but it's what I heard. It's that, it's kind of like a stair model, right? Like, you want someone in your language to be able to write the whole stack themselves. So they get on at the bottom stair and they're like, I need to send a datagram packet. I need to receive a datagram packet. Fuck everyone else, right?
Right.
And then at the top, it's like, here's an HTTP request object. I want to send it to this URL object and get back an HTTP response, or something like that. So it's like you have all these different layers, and it's not 2 layers. It's like there are,
right,
each one is a discrete API, and you want to be able to use a higher level API and a lower level API without implementing everything in between. And that's the challenge, I think, Yorick, is, if I implement a part down here that's related to TLS, can I rely on that from up here where I'm using a RESTful client API or something like that? Can I have it go through my code to do that TLS thing? Because I'm doing some debugging and I want to see that data flow through my other library. And that's where it gets difficult, because you're composing. If at the high level, you're jumping off directly into the some other library, it's not going to call you back usually without a lot of work to go into that, lower level piece that you built. I don't know if I explained that very well. It was very confusing for me too.
I get the difficulty of it here. Well, why don't we call it early? I have a lot of things to do and I'm traveling internationally tomorrow.
Maybe.
Yeah. Yeah.
If Microsoft comes back online.
Yeah, if the internet doesn't collapse on me and I go to the airport and there's no one's terminals work, so I can't check in. The $1 billion aircraft sitting on the runway full of jet fuel, but can't take off because you can't check in.
How Microsoft proves they're worth being $1 trillion company. Show that the world can no longer function without them.
Not so that they're reliable, so that the world can't function without them. Okay.
And someday we should get an update from Artur on what he's been up to, because he's always answering questions for us, but never telling us much about what he's doing.
Okay, but not today. Next week. 2 weeks.
So
2 weeks.
for the last, I don't know, for the last, I don't know, year and a half maybe, I was managing the team, so I didn't actually have time myself to
Went to the
to
dark
work on
side.
this personally. But I can think of some interesting examples of our work.
Cool. Looking forward to it.
All right, and I'm traveling internationally. I don't think I'll run Coffee Club next Friday. If I do, I'll announce, but I suspect I will not be in the correct time zone for my brain. And so I will be happily sleeping it off as opposed to attempting to run Coffee Club. So 2 weeks.
You're gonna send Tidor a code so he can open the room?
If people
Yeah,
want to,
Yes.
are you interested?
Yeah, why not?
Nothing's changed in a year, so everything's all there.
Mm.
There's the Zoom window, which is, I have to probably approve it.
What?
From Crete, the first thing they'll say is somebody, not you, in some country in Russia, Belarus, no, somewhere over there, is trying to open up your Zoom account, and I'm going to respond to you from Crete, and they're going to look funny at this.
Let's not do that. If we are for the next CCC, I will open a room and see who will join.
So the next CCC afterwards is August 2nd, and that Ben Titzer claims he's going to be there. So that will be exciting. Right. If it can fall together, I'll take it, but I'm not going to push hard on a CCC next week.
Okay.
You can reach out to me after the meeting here, and we'll talk about what you would need to make it to fire off, Theodore.
Okay, cool.
Okay. But I need to go here.
So reach you on Discord.
Yeah, reach on Discord is fine.
Okay. Okay.
Bye-bye.
Bye.